Okay, so the No Coast is it's a single voice patchable synth, and it's 100% analog signal path. It is like the fixed signal path architecture is similar to a traditional mono synth, and it kind of goes from left to right. And it's called the No Coast because it kind of it draws parallels from the East and West Coast synthesis paradigms. So you have more of the subtractive versus additive synthesis and Moog Buchla kind of paradigms that are all represented equally in this synth. It is designed to work without the use of any patch cables, so you don't necessarily need to patch certain things into each other to get a sound out of it. You don't have to turn it up too much. But obviously, it's semi-modular, so you can bypass certain internal routings by patching certain outputs into inputs. That's kind of the overview. It has a bunch of different activity windows, as you can kind of see here, and each activity window does different things, which we'll go into more detail as we get into the demo. Some of them show the polarity of a signal, some of them show the signal strength, some of them, this one is just showing the clock signal here. So those are just a visual representation of what's happening inside the synth. So that's kind of an overview.
All right. The normalizations are, as you can see, there's a lot of gold lines, and that kind of shows you what are the pre-existing internal connections. So they're relatively very easy to follow. So the first section on the right here is the MIDI section. Let me get a show of hands. How many major MIDI heads do we got here? Okay. So what it looks like is we got a bunch of modular heads here. All right. I dig it. But fear not, this thing does have some really, really good, useful MIDI functionality. It uses a 1/8" tip ring sleeve for the MIDI input. It's similar, if you're familiar with like this guy, the Korg SQ1 has a mini plug MIDI connection on it. It comes with, in the box with it, comes with the adapter. It doesn't have their traditional MIDI DIN on it, so that's what I'm saying, it uses that and the adapter that comes with it. The MIDI is set up so that its default is that it receives MIDI on all channels, and you're able to select what you want to go out of the two different MIDI outputs that are down here. MIDI output A is always normaled to the 1 volt per octave on the oscillator, and it is normal to the gate input, and you can see that by the gold lines, the gate input for the contour generator, the envelope generator. Let me see what else. We have a little cheat sheet here that's helping us remember all this stuff. There's some MIDI activity windows that are like here and here that will flash red when you have MIDI activity going on. There are a couple different program modes. There's only, when you hold down program A, it'll flash, and let me see if I can get this to do this. Yeah, so it's flashed, and then from now it's in MIDI program page number 1. There are 7 pages. If you ask me right now what all 7 pages are, I can't tell you. It's in the manual. If we don't need to go that deep on the MIDI, I won't. The first mode is an arpeggiator mode. There's a legato mode. There's setting up what do you want to do with MIDI B. It has a learn function as well, so that it can learn specific channels. Yeah, I said there's the first thing that is program page 1 for the MIDI is the arpeggiator modes. I believe it's page 4 is you're able to set it to where if you're not going to use MIDI on MIDI B, then the CV and gate out of MIDI B are a tap tempo LFO. So that's kind of helpful for us with our modular stuff. And out of the CV out is a triangle wave, out of the gate out is a square wave. Yeah, that's kind of a little brief overview of the MIDI. I can't remember all 7 pages, but they are in the manual, and the manual's online. It's really set up, really basic, really easy. You can plug a MIDI keyed synth into it with the adapter and start banging away on the keys. Flip it into the arpeggiator mode and start doing, there's 2 different types of arpeggiator in it. There's a latching one, and there's one that's a shifting latching arpeggiator. So they're both like really fun.
Where are the square and triangle waves?
They're out of MIDI B output, and that's when you go to, I believe it's page 4, page 4 of the MIDI program modes, which this is in 1 right now. You use B to, when you hit B one time, it goes to another page. Or no, I'm sorry, it's A is the one that goes to another page.
So it's programmable.
Yes, it's very programmable.
Okay.
And you can generate a secondary LFO, which can be triangle or square. So the secondary square LFO comes out of the gate, out of MIDI B gate, and then the secondary triangle LFO comes
That's on, like I said, that's on MIDI program page number 4. Great. So you can set to use that, and then program A then is what you use to tap the tempo of that LFO. So it's kind of similar to some other tappable frequency LFOs in Eurorack. So Ben is going to tell you about the next section.
So I got a question on arpeggiators. How many arpeggiator modes are there? Up, down?
There's just 2. And I believe
One is latching, and then one is some kind of a hybrid arpeggiator mode where you can play up to 20 notes, and it'll kind of switch between them.
Like an assign mode?
yeah, well, it's kind of like a shift register arpeggiator where you can add up into a certain, I think it's up to 20 notes, and then as you add more, other notes will drop off. And I think that's arpeggiator mode 2, and the first one is just a pretty standard latching arpeggiator that I believe it's up is the actual direction of it. Okay, Vanna's going to tell you about the voltage processor.
Did we talk about that? And just to backtrack a little bit, I don't know if it's easy for you guys to see here, but there are a lot of normalizations on this synth. And those are kind of pre-existing patches. So and those are all indicated by the gold wires. Are you able to see that? So,
Yes, there's gold lines.
Yeah, so all these, it's probably easier if I point here. So for, just as an example, this triangle wave, there's a gold line that kind of runs across here and then into the balanced circuit. So all the gold lines that end with an arrow into an input jack, those indicate the normalizations, which are internal routings, just like a typical monosynth that is not modular or patchable. It's just showing you that on the faceplate. So that's something to remember. So that's all the gold wires. So over here we have the in this section it starts with a tap tempo up here. And then this is the tempo input jack, so you can control it externally from a different synth. So you can just send it a gate or a trigger signal to the tempo in. And then this is the clock out, and this is the LED that kind of shows you the tempo that you've tapped. And this is your tap tempo. And then under the clock output, there is a sample and hold circuit, so that's built in. And then over here, we have the CV processing circuit. So is anybody here familiar with the maths? Hopefully you are, with the make noise maths. So this would be like channels 2 and 3 of the maths. So it's your CV processing circuit. And so you have 2 different channels here. Maybe we can unplug it so we can see it a little better. So the first channel takes signals at unity, meaning that you have no way to attenuate the signal or invert it. And then the second channel comes with a built-in attenuator, so you can scale and offset and just do different kinds of CV processing. Yeah. So with nothing patched, you won't get anything, but if you put a positive offset. So that is the CV processing circuit, and the outputs are summed on this one, and that's indicated by the sum.
Next, I'm going to talk about the oscillator section, which is there, which it's a triangle core. It's an analog oscillator voice, triangle core, and it has a coarse tune, fine tune, 1 volt per octave. The 1 volt per octave can also be your exponential FM input, has a linear FM input.
Okay, so moving along to the timbre circuit. So this whole section, which is in the middle of the synth, really is the basis of the just why, like, what makes this such a unique monosynth actually. So again, we can see there's these gold lines that kind of they are normal to the overtone and multiply circuits, and these two circuits are also, they are normal to the balanced circuit, which we will touch on again later. But there is a gold line, if you can see it, comes out of the multiply, up, around, and then it ends on the right side of the balanced circuit, which it's labeled, what is it labeled here? Overtone, yes, exactly. So the overtone circuit basically adds overtones that are still harmonically related to the fundamental pitch. And then as you start to turn it clockwise, it goes from odd to even. So it just changes the timbre, and it's easier to hear than to explain. And then so the overtone has you have CV control over the overtone over here. And then the overtone circuit is normal to the multiply circuit. And what the multiply circuit does is that it basically adds whatever harmonic you've kind of honed in on the overtone is multiplied. And the multiply circuit comes in, it comes with an onboard attenuator and a activity window here, and you have CV control over the multiply as well. And then all of this kind of goes in again to the balanced circuit. And this is kind of a nod to West Coast synthesis, because you're dealing more with additive synthesis. You're adding harmonics and creating more of a rich tone, which is the opposite of just the typical subtractive synthesis, which is the basis of East Coast synthesis. Does anyone have any questions about that circuit? The whole thing.
We have this thing set up to where you can hear overtones being added, or select one and then multiply it. So you can get some really awesome sweeps. So if anybody out there has a DPO and you really like the sound of your DPO, this is going to be pretty similar and sounds really, really awesome. So yeah, instead of doing filter sweeps, we're doing harmonic sweeps, additive harmonic sweeps, which is very, very West Coast, very unique sounding, yes, for sure. The next section here of the no-coast is the slope generator. So everybody, got a bunch of modular heads in here. Who's got a maths or a function? All right, so then you'll be pretty familiar with this. So it's really, really similar to channels 1 or 4, the maths or a function. So your cycle button is on the top here, and then when that is engaged, where you can hit that, and I'll make this a little slower. So you can see you have an activity window that's showing you actually what your voltage is doing. It's a 0 to 8 volt signal, unipolar. You have your rise and fall that is how fast your signal goes from 0 volts to 8 is your rise. Fall is from 8 volts back to 0. You have your variable response here, very similar to, it's on maths and function. So you can set it to logarithmic, linear, or exponential. There is a time CV input, and that's a shared for both of them. So if you're using it as a secondary envelope to, like, let's say the contour envelope that has its own decay input, and you're like, hey, I want decay over a secondary envelope. Well, you can set your rise time because it's an exponential response on that time CV. So if your rise is all the way down at 0, it will you're not really going to get too much variation in that. Where you'll get, it's going to be very hard to tell the differences in your rise time. But your fall is where it'll really play out and be similar to a voltage-controlled decay circuit. You have an end of cycle gate output, very similar to channel that's found on channel 4 of the mass and on the function. You have a trigger input so that you can externally trigger it, and then you have its voltage output as well, so that you're able to route that to other places. And it is internally normaled to the multiply circuit in the timbre section. So it's a pretty basic slope generator. And the next one is the balance. We're gonna go to the balance circuit.
Okay, so the balance circuit, we kind of touched on it earlier. So it's basically a balance between just your straight oscillator, so the triangle wave, and then a balance, and then as you turn it clockwise, you're getting more of the overtone. So now it's set on, put on full, yeah. So the triangle wave again is normaled. So there's a gold wire up here that comes out of the triangle wave and then into the left side of the balance circuit. So if you want to hear the square wave, you have to like physically patch it in. And then so the balance panel control is fully, yeah. As you turn it clockwise, you start to hear more of the overtones, which are generated by your overtone and multiply circuits. And you have CV control over the balance, so you can plug in a sample and hold or whatever you want to kind of control the wet dry almost between the fundamental tone and the overtones generated by the timbre section. And this input can also be the input for any external signal. So if you want to patch a saw wave from a different synth, you can put it in here and still take advantage of the overtones as well.
So to clarify that, that's not routing a signal to take advantage of the overtone section. That's basically like an external audio input. You want to plug your iPod into it, you want to plug a drum machine into it, another synth, that's where you can do it. And then you can take advantage of using the dynamic circuit, which is the VCA of the No Coast, as such, whether if you want to, VCA something off an iPod or another synth, that's how you would input an external sound into it. And then the dynamic circuit down here is it's a non-resonant low-pass filter VCA, and it's transistor-based. It's inspired by the Buchla 292. So I'll try to get a little sound going while this is going. So you have an activity window here that shows you kind of what's going on, and I'll make this pretty bright. So you can hear that not only is it controlling the amplitude, but it is getting brighter as it gets louder. So it is a non-resonant, I think it's a single pole non-resonant filter. Yes. So and this is obviously this is it is like I said, it's inspired by the Buchla 292. But yeah, I mean, pretty much functions like a pretty normal VCA. That you have CV control here. You can externally control it if you want to, send another envelope in from a math or from your modular. If you are using it to, let's say, VCA an external synth. Down below there, you have your line out, which is a stereo 3 volt peak to peak line out, which is your kind of normal line level audio out, which is good for headphones if you're jamming by yourself or to use with a lot of other line level gear. And then your dynamic out that we have this cable plugged into right here, that's your 10 volt peak to peak modular level output, which is a very, very hot signal that be sure to be careful what you run that into, because it can fry some other stuff. So it's three times stronger signal than a normal line level signal. So and that's what we are routing in our patches here from it back into the modular for use and basically mixing and processing in the modular. Was there any questions about the balance circuit or the dynamic circuit or the main output of the no coast? Yes?
To use the square wave, does it basically have to go into the dynamic and that would override it, putting something external into it?
Yes.
Plug it into the balance up here.
Yes, because the square wave is what's used to add the harmonics to the triangle.
Oh, okay.
So if you do want to just use that, so you can hear that that's just straight square. And there's how.
So this is the square, and then this is the triangle.
Yeah.
And then
So you can hear that. You can also hear this. You can hear this VCA as it filters as well. So that's pretty normal square right there.
So the contour is basically a 4-stage function generator that drives the dynamic circuit, which basically is the final VCA. And this is inspired by the loudness contour circuit on the Mini Moog Model D. So it's basically inspired by that. So that's another nod to East Coast synthesis. So it can be a 2, 3, or 4-stage envelope depending on where the sustain knob is. So if your sustain is fully counterclockwise, and it's just going to be an attack and decay envelope. If it's fully clockwise, and it's going to be an attack, sustain, decay envelope, or attack, sustain, release envelope, a 3-stage envelope. And if it's anywhere in the middle, it becomes a 4-stage ADSR, just typical ADSR envelope. And you can control, it can be linear or exponential in terms of the response curves. And for those of you who are not familiar with the loudness contour circuit on the Mini Moog, the decay knob controls the release and the decay. So it controls how long it takes it to get to the sustain level, and then how long it takes the note to release. So the onset up here is like your attack. Sustain is the max level, and decay is decay and release. So it's the same knob for both. And this is your response, so linear exponential. You have CV control over the decay stage of the envelope. This is your gate input, so it's kind of labeled like all of the make noise stuff, so it's expecting a trigger or a gate signal, so it's kind of the input is surrounded by circles. That's the indication. Oh yeah, so the gate input is normal to the MIDI A gate, so that's also indicated by the gold line. So out of MIDI A gate, so it's normaled into the contour circuit, which drives the dynamic circuit. And then the EON here, this is the output, which is end of onset. So when it gets to the sustain stage, basically it sends out a trigger, a trigger signal, probably a 5-volt trigger signal. And then the contour, so this is also normal to the dynamic circuit. So you can see this arrow that ends here. So with nothing patched into the dynamic circuit, it's automatically going to default to whatever envelope you set with the contour circuit.
This was the voltage output too, if you wanted to use that same envelope to VCA something or FM something. Yeah, but in a whole, that's pretty much it. It's an awesome little desktop patchable synth that sounds really awesome. Was there any questions about the no coast or anything that we touched on?
So it's called the no coast?
So yeah, it is called the no coast, the O coast, or the zero coast. It's any one that you want. Any of those three, that is what it is. The O coast, zero coast, or no coast. One of three names. It's $4.99. Want to check it out, and thanks everybody for coming, and thanks everybody for supporting Make Noise.
So you got 4 of